Okay, let's continue by question number 8. Alright, so what do we have now for question number 8? Figure 3 shows a graph of displacement y against x for a progressive wave propagation to the right in a string with mass 920 gram, length 3 meters and tension 15 Newton. Determine the progressive wave equation. Alright, so now for this question, okay, a graph given now which is y against x. So we need to know what graph is that. So y representing the displacement of the particle which is oscillating upwards and downwards, while x representing the distance of the wave which is propagate to the left or to the right, isn't it? But according to the question, the wave now just propagate to the right. So we need to know that kx should be negative. Okay, so this is the info given. Basically, okay, from the graph, the values given is 12 centimeter and 50 centimeter. So we need to know what values is that. So 12 centimeter now representing the amplitude of the particle which is oscillating upwards and downwards. So this is the maximum displacement of the particle, which is amplitude. So amplitude is 12 centimeter. We just convert it to be in meter, giving you 0.12 meter. Okay, and then 50 centimeter also given here. Okay, what values is that? Okay, so remember this is the distance of wave propagation. So this is under length lah. So 50 centimeter. So what value is that? Please refer to this curve. So this curve now representing 1 lambda, isn't it? So that now we have 2 lambda. So 1 lambda plus 1 lambda giving you 50 centimeter. So this is the total length of 2 lambda. So that 2 lambda equals to 50 centimeter. Or we just convert it to be in meter, which is 0.50 meters. So that we may calculate lambda, where lambda equals to 0.25 meters. Okay, so amplitude and lambda given already. So other information given now is, okay, the first one, propagate to the right. So we know that kx should be negative. And then the mass of the string is 920 gram. So we just convert it to be in kilogram. This is the mass of the string. And then the length of the string is 3 meters. Okay, and the tension exerted on the string is 15 Newton. So the question asks you to determine the progressive wave equation. So what is the wave equation? Alright, so basically we know that the wave equation now is y equals to a sine omega t minus kx. But according to this situation, amplitude given already, which is 0.12 meters, isn't it? But omega and k is not given here. So that we need to calculate omega and k. So basically, we just start by k. We just calculate k using the equation of k equals to 2 pi over lambda. So lambda getting before is 0.25 meters. Substitute into this equation, giving you k, which is equals to 25.13 per meter. Okay, so this is k, settled already. And then we have one more unknown here, which is omega. So we need to calculate omega. So by using the equation of omega equals to 2 pi f. Then the frequency is not given here. We need to calculate the frequency. So to calculate the frequency, we just refer to the equation of v equals to f lambda. So f equals to v over lambda. Lambda given already here, but v is not given, isn't it? The velocity. So to find the frequency, we need to know the velocity of the wave on the stretched string. So that we need to calculate the speed first. So using the equation of speed of transverse wave on a stretched string, which is equals to square root of t over mu. What is that? Tension divided by mass per unit length. Mu representing the mass per unit length. Okay, so the tension given already, which is 15 Newton, substitute here. And then mu is mass per unit length. Mass given already, which is 0.920 kilogram, while the length is 3 meters. We just substitute these two values into this equation. And then we may calculate v. By getting v, and then we just substitute into the equation of f. Okay. And then you will get the frequency. By getting the frequency, and then we just substitute into the equation of omega here, and then you will get omega. So by getting K and omega, so just substitute into the general equation before, amplitude known already. K and omega calculated just now, substitute into the equation. So this is the equation of this wave. And remember, don't forget the unit, where X and Y just in meters, okay, because we have converted everything to be in meters, isn't it? All right, and T in second. So for any question to be like this, don't forget to write down the unit here. Okay. Okay, next question number 8B. Okay, read the question first. A 1.53 meters closed pipe makes a humming sound at frequency 282 Hz when the wind blows across the open pipe end. The speed of sound in air is 343 meters per second. With the help of a diagram, determine the number of notes in a standing wave. Okay, so by using a diagram, okay, they ask you to determine the number of notes in standing wave. Okay, first we need to know what apparatus do we have. So according to this, we are talking about the closed pipe. Okay, so remember we have three different apparatus, which is stretched string, a closed pipe, and also an open pipe. So now please focus on closed pipe. So for any closed pipe, okay, one end should be open and another end should be closed. Okay. Alright, so first, as usual, we just find the info given in that question. Okay, first, what do we have? A 1.53 meters closed pipe. This is the length of the pipe, L, which is 1.53. And then the frequency of sound given already, which is 282 Hertz, the frequency of sound, and which is blows across the open side. And then the speed of sound wave given already, which is 343 meters per second. Okay, with the help of a diagram, determine the number of notes in standing wave. Okay, basically, this is the equation of frequency of closed pipe, which is Fn equals to Nv over 4L. So N is the number of harmonic, V is the speed of sound wave, and L is the length of the pipe. Okay, so how do we know what is the value of N? Is it all integers, which is 1, 2, 3, 4? Or we are talking about the odd numbers only, which is 1, 3, 5. Okay, let's recall back what do we have for any closed pipe. Okay, for the closed pipe, as we know, for the fundamental mode, this is the pattern. We just have one knot and one anti-knot. So remember, anti-knot always at the open side because it's very free for the molecules to vibrate at maximum amplitude, isn't it? So anti-knot should be located at the open side. At the closed side, it must be knot. Which is under destructive lah. Okay, so for the fundamental mode, we have this. So based on the derivation before, now we are talking about quarter lambda. L equals to quarter lambda. So lambda equal to 4L. From the equation of V equal to F lambda, so that F equal to V over lambda. Substitute lambda equal to 4L into this equation, then you will get F1 equal to V over 4L. So fundamental mode also known as first harmonic. Okay, for the first overtone, okay, we just start by one knot and one anti-knot, isn't it? For the first overtone, we have 2 knot and 2 anti-knot. Okay? Okay, how many lambda do we have? Quarter lambda, and quarter lambda. So we are talking about 3 quarter lambda, which is equal to the length of the pipe. So by rearrange the equations, lambda equals to 4 over 3 L. So again, using the equation of F equal to V over lambda, substitute lambda into this equation, giving you V over 4 over 3L. By rearrange the equations, you will get this, 3V over 4L, where V over 4L now representing F1, giving you 3F1. So 3 here representing N, okay, which is Fn equal to Nf. So N equals to 3 lah. So F3 equal to 3F1. So after fundamental mode, it's just followed by the first overtone. First overtone representing the third harmonic, which is N. N is harmonic. Okay, so third harmonic. Okay, next, first we just start by 1 knot and 1 anti-knot, followed by 2 knot and 2 anti-knot. Next, 1, 2, 3 knot and 3 anti-knots. Okay, so fundamental mode, first overtone and second overtone. Okay, for the second overtone, how many lambda do we have? Quarter, 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 one complete lambda, another quarter, giving you 5/4 lambda, which is equals to L, length of the pipe. So by rearrange the equations, you will get lambda equals to 4/5 L. So from the same equation before, F equal to V over lambda, substitute lambda here, and then giving you this equation. By rearrange the equations, you will get this equals to 5V/4L, where V/4L still equals to F1, giving you 5F1, so that this is Fn, which is NF1, so N equals to 5, giving you F5 equals to 5F1. So the second overtone giving you fifth harmonic. Okay, so this is the way, remember. So now, with the help of diagram, determine the number of notes. Okay, now, from the info given, which is L, F, and V. Okay, for any closed pipe, this is the main equation. So, frequency given is 282, V given is 343, and the length is 1.53. Substitute into this equation so that you will get N. So, N getting out is 5. So, we are talking about the fifth harmonic. So, which one is fifth harmonic? Okay, fundamental mode representing the first harmonic, followed by the first overtone, which is the third harmonic, and the second overtone now representing our fifth harmonic, isn't it? So for the fifth harmonic, they ask you to find the number of notes. How many notes do you have? 1, 2, 3. So the number of notes equals to 3. Okay. So this is the way how do we use the diagram lah. Okay, so you need to know how to differentiate between a closed pipe and an open pipe cases. Alright. Okay, next question number 8C. What do we have? Okay, the frequency of whistle by a moving train. Okay, whistle of a moving train. So the sound produced by the train. So we know that the train is the source. Okay, and the frequency heard by a stationary observer. This is the main keyword, observer, which is in stationary or static. Okay, are 520 Hz and 460 Hz respectively. Alright, so this is the frequency of the whistle by the train, which is moving now. Okay, which is the source. And this is the frequency heard by the observer, which is at stationary lah. Okay, or at static position. Alright, so frequency of source, frequency received by the observer. Okay, if the speed of sound in the air is 343 meters per second, calculate the speed of the train. So, okay, I think better we just simplify everything here using a simple diagram. So this is the train where the frequency of the whistle note is 520, and this is the observer, and the frequency heard by the observer is 460. Alright? Alright, so the observer just at stationary, it doesn't move, so V of observer equals to 0. The train is moving, but we doesn't know in which direction is that. Is it moving away or towards? Okay, this one is not the speed of the train. This is the speed of sound wave. Okay, let me delete this to avoid any confusion. V representing the speed of sound wave is not the train. And the speed of train should be here. Okay, I need to delete this one to avoid any confusion. This is V of train, which is Vs, which is unknown source. Okay, V of sound wave given already. V of sound wave is 343 meter per second. Okay, that one different. Alright, so we are discussing about the Doppler effect. The equation of Doppler effect is F, frequency received by the observer equals to V plus minus V of observer divided by V minus plus V of the source multiplied by the frequency of the source, isn't it? So in this case, the observer just keeps static, so V of observer equals to 0. Okay, now, how do we know? The values at the bottom side here should be plus or minus. Okay, please refer to this. The frequency received by the observer is lesser than the frequency of source. Okay, this is frequency of source lah. Okay, this is the frequency of observer. Okay, lesser. So means that this is the frequency received by the observer, and this is the frequency of source. So frequency of received by observer lesser than the source. So the value at the bottom here should be greater, isn't it? Because they are inversely proportional. When the values at the bottom here is greater, giving you smaller f here. They are inversely proportional. So it must be plus. Okay, means that the frequency received by the observer is lesser than the source, means that the source is moving away. In simple words, when the source is moving away, the sound heard by the observer become weaker. Okay, so that the frequency also lower or smaller than the source. Okay, so this is the way lah. So this is the frequency received by the observer. This is the frequency of the source. This is the speed of the sound wave given already here. And this is the speed of the train. So they ask you to find the speed of the train. We just substitute all the values. Then we may calculate the speed of the train, which is 44.74 meter per second, which is moving away. Okay, so again, how do we know that the train just moving away? Because the frequency received lesser than the frequency of the source. Okay? Okay, next question number 9. A progressive wave is represented by the equation. Okay, something is wrong here. Okay, we just cancel out this. Okay, so a progressive wave is represented by the equation y in terms of x and t, which is equals to 2 sine pi t plus pi x. Okay, where y and x are in centimeter and t in second. So calculate the velocity of the wave. So from this equation, they ask you to find the velocity of the wave. Sketch a graph of displacement against distance for the range between 0 until 2 lambda for x at time t equals to 0. Also sketch a graph of displacement against time for the point at x equal to 0, where the range of t now is between 0 until 2 period. Okay, so now this is the general equation given now, which is y equals to 2 sine pi t plus pi x, where y in terms of x and t, because we are talking about x and t here, isn't it? So this is the equation. Y equal to a 2 sine pi t plus pi x. So by comparing this equation with the general equation, which is y equal to a sine omega t plus kx, we know that a given already, which is 2 centimeter, omega equals to pi, and k also equals to pi. So this is the hidden info. So by asking you to calculate the velocity of the wave, okay, we need to calculate v. So v equals to f lambda. Based on this equation, f and lambda is not given, isn't it? But we may calculate f and lambda from omega and k. So as usual, using the values of omega also k, we just find f and lambda. So omega equals to 2 pi f, where omega equals to pi. So pi equals to 2 pi f. Pi and pi cancelling each other, giving you f equals to 1 over 2, which is 0.5 hertz. And then by using k equals to 2 pi over lambda. K given equals to pi. So pi equals to, or by rearrange the equation first, k equals to 2 pi over lambda, lambda equals to 2 pi over k. We just transfer k and pi to the other side, giving you this, where k given now equals to pi. Substitute k equals to pi, so pi and pi cancelling each other, giving you lambda equals to 2. But remember, the unit is centimeter. Alright, so by getting f and lambda, we just substitute into this equation. F getting before is 0.5 hertz and lambda is 2 centimeter, giving you 1 centimeter per second. So as we know, the SI unit of speed is meter per second. So we just convert the unit now to be in meter per second, so that you will get V equals to 0.01 meter per second. Okay, for the second question, they ask you to sketch a graph of displacement against distance, where at t0, the range of x is between 0 until 2 lambda. Alright, so how is it? By asking you to sketch a graph, you don't have to calculate, because we don't have to plot the graph. We are going to sketch a graph only. So at t0, the range of x now between 0 until 2 lambda. So there must be 2 lambda in our graph. Okay. Alright, so the equation is y equal to 2 sine pi t plus pi x. This is the equation given, where t equals to 0, cancel out t here, so that the equation becomes y equal to 2 sine pi x. So the graph is y against x, where the graph is purely sine. So y against x graph, the graph is purely sine, but remember, the range now is between 0 until 2 lambda, so this is 1 lambda, and this is 2 lambda. Alright, because y against x, remember, y representing the displacement of the particle which is oscillating upwards and downwards, and x representing the distance of the wave which is propagating to the left or to the right, isn't it? So by having x which is under length, so the x-axis is now representing lambda lah. Okay, so 1 lambda and 2 lambda. Don't forget to label the graph. Okay, amplitude given is 2 here, amplitude is 2, and then lambda is 2 centimeter. How do you know? From the calculation before, lambda is 2 centimeter. So 2 centimeter, 1 lambda, another 2 centimeter represented another 1 lambda. Okay, so we have 2 lambda already. Still the same for the question C. They ask you to sketch a graph of displacement against time for x equal to 0, where the range now is between 0 until 2 period, the range of time between 0 until 2 period. Okay, so by doing the same thing, the equation is y equal to 2 sine pi t plus pi x. Okay, where x equal to 0, cancel out x, so the equation now becomes y equal to 2 sine pi t. So the graph is y against t, where the range of t is between 2 until 2 period. So take out a graph of y against t, and the graph is purely sine again. Purely sine, start from 0 and moving to the amplitude there. Okay, and then don't forget we are talking about 2 period. Okay, y against t, so t representing time. So 1 complete lambda here representing period, isn't it? So this is 1 period and this is 2 period, because the range now is between 0 until 2 period. So we have to complete 2 lambda here lah, 1 period for 1 lambda, and another 1 period for another lambda. Alright, so again, label the graph. This is the amplitude, which is 2, and period also 2. How do you get that? From the frequency. Frequency is 0.5 Hertz. So as we know, period equals to 1 over f, which is 1 divided by 0.5, giving you 2 seconds. Alright, so we just label it by 2 seconds. Also 4 seconds. Alright, so this is the way how do we sketch a graph for any wave by giving you the equation. Okay, next, let's start by question number 10. Okay, I want to focus on calculation only. So 10A, you may answer it. Okay, the answer I think given already in the notes. Just copy and paste, yeah. Okay, 10B. A progressive wave is represented by following equations, which is y equals to 10 sine pi over 4t plus x, where y is in centimeter and t in second. Determine the direction of propagation and the wavelength. Alright, so this is the general equation given now, which is y equal to 10 sine pi over 4t plus x. And as we know, general equation of wave is y equal to a sine omega t plus kx. So from the equation given, we know that this is the amplitude, this is omega, which is pi over 4, and this is k, which is equals to 1. Okay, first they ask you about the direction of wave propagation. So plus kx means that the wave just propagate to the left. Okay, second they ask you to find the wavelength. Okay, how do we find the wavelength? Okay, from the equation of k equals to 2 pi over lambda, where k given now equals to 1. Substitute into the equation, so that lambda getting now equals to 2 pi centimeter. See, physics is too easy actually, yeah? Okay, and then for the last question, which is number 10C, Okay, please refer to 10C2. 10C1, the answer is given already in the note. You may copy it by your own. Okay, C2, again under calculation. A 0.5 kilogram object is hung at the end of the string of mass of 72 gram and length 1.2 meters. Calculate the speed of the wave propagation in the string when the system disturbed. Alright, so now there are two different masses here. Don't be confused, which is 0.4 is 0.5 kilogram and 72 gram. So what mass is that? Okay, this is the mass of object which is hanging at the end of the string. And this is the mass of the string. That is why it's quite lighter, isn't it? Lighter than this, which is 72 gram only, the mass of the string. And this is the length of the string. And mass of the string, length of the string. So they ask you to calculate the speed of the wave propagation in the string. So we are talking about the transverse wave, okay, formed on the stretched string now. Alright, so what do we have? Mass of hanging body, which is 0.5 kilogram. Mass of the string, which is 72 gram, converted to be in kilogram. Length of the string, which is 1.2 meters. They ask you to find V. Alright, so how was the situation? This is the situation lah. This is our stretched string. So by vibrating one end of the string here, what happened? The transverse wave produced. So they ask you to find, okay, we are talking about a transverse wave. It's not a standing wave. So let me cancel this. Transverse wave only, sorry. Okay, transverse wave. Okay, so this is the transverse wave produced. They ask you to find the speed of the transverse wave. Okay. Okay. So now, how to calculate V here? So as we know, the speed of a transverse wave on the stretched string is V equals to square root of T over mu, which is tension over mass per unit length and square root. So in this case, we need to find the tension, also the mass per unit length. Okay, mass per unit length is mu, which is M over L. So remember, mass of the string and length of the string given already, which is 0.072 kilogram, and the length is 1.2, giving you 0.06 kilogram per meter. So this is mass per unit length of the string. Alright, at the same time we need to find the tension. So tension equal, alright, so this is the tension exerted on the string, where the tension here and here, they are equal to each other. We are talking about the same string, where the tension now equals to weight, according to equilibrium. T minus W equal to 0, so that T equals to W, which is W equals to mg. So mass here equals to mass of the hanging body, which is 0.5 kilogram. So m is 0.5, g just gravitational acceleration, which is 9.81, so that you may calculate W, which is equals to T, which is 4.905 Newton. So by getting mu and T, we just substitute into this equation, so that you will get the speed of the transverse wave on the stretched string now is 9.04 meter per second. Okay, so this is the way how to answer the question. It's quite simple, isn't it? So basically, we need to know what info given in that question, and sometimes we need to figure out, okay, what situation actually given in that question. I think better by doing this, you may answer any question. Okay, I think that's all. Thank you. Assalamualaikum.